So let's begin Chapter 5, Build a Plot Layer by Layer. We're skipping Chapter 4, and this first video begins at the beginning of the chapter on page 89 and progresses up to the section on setting versus mapping that begins on page 96. So far what we've done mainly is created a plot with ggplot and then added on a layer with the geom function. But it's important to realize that there are really two distinct steps. First, we create a plot with the default data set and aesthetic mappings, like here, and we're just building the frame. We haven't added any layers to display anything yet. So we need to add one layer, the first layer, so we can see something. So we'll just say geom point. Now we see the points. Geom point is really a shortcut, or sometimes called a wrapper function. It actually does 5 things at once. When you call the geom point layer, what you're doing is you are specifying the mapping, the data, the geom, the stat transformation, and the position. Now, all of these calls within the geom function have default values that you can override. At this point, mapping is null, data is null, the geom is a point, stat is identity, and the stat parameters are a list, and the position is identity, which means keep them as they are. Okay, so that's what this says here. Mapping is a set of aesthetic mappings. We use AES function combined with the plot defaults. Data is a data set which overrides the default plot data set. Geom is the name of the geometric object used to draw each observation. Stat is the name of the statistical transformation to use. Position is the method used to adjust overlapping objects, like jittering, stacking, or dodging. Now you see up here all of these 5 specifications, these 5 components, have default values, but we override them. For example, in data, we tell it what the data set is, so that it overrides the value of null. Now, every layer must have some data associated with it, and the data must be in a data frame with the variables in the columns and the observations in the rows. The data on each layer doesn't need to be the same, and you can combine multiple data sets into a single plot. Of course, that gets more complicated. Now, the aesthetic mappings that are defined with AES, where you specify the variables that are to be mapped to particular visual properties of the plot. Typical aesthetic mapping will be X will be the displacement variable, Y will be mileage on the highway, and color will be associated with the class variable. Okay, so that's what we're doing in this aesthetic mapping. Now you can leave out the names for X and Y. You could just say AES displacement, comma, highway, comma, color equals class. Whatever you put in the first position will default to X, and whatever you put in the second position will default to Y, even if you omit the names of those arguments. So that is the same. These two are the same. This is the same as this. Now, aesthetic mappings can be supplied in the initial ggplot call, or in individual layers, or in some combination of both. For example, all of these 4 calls to ggplot all produce the exact same plot specification. And note that in the first, we're making the call to the aesthetic mappings directly in ggplot. In the second, we're making part of the aesthetic mappings in geom point, color equals class. In the third, we're making aesthetic mappings in geom point where we're telling it what Y is and what color is, what color should be mapped to, and it's mapped to the class variable. And then in the fourth, we're making all 3 of the aesthetic calls to geomePoint. Now, with only one layer of geomePoint, it doesn't matter. All of these will produce the same plot. So there it is, first time. Second one, same. Third one, same. Fourth one, same. So the resulting plot from all four of those calls to ggplot are the same, and we've just mixed around where the aesthetic mappings are placed. And the point is, if you only have one layer to the plot like we do here, then the way you specify aesthetics doesn't make any difference. But it does become important when you start adding additional layers. Let's take a look. So here we're going to add, instead of just having one additional layer geomePoint, we're going to add a second layer. So we have two layers in each of these plots, geomeSmooth. And we're going to, geomeSmooth just draws a regression line, either a curvy regression line or with LM, a linear regression line. Okay, so the first one we're saying, we're specifying the aesthetic mappings all in the call to ggplot. Under the, putting AES as the second argument in the call to ggplot. And then we add the points, and then we add a geomeSmooth with a regression, that is a regression line. And note what it does. What this configuration of our call does, it actually adds a separate regression line to each of the subsets of data, okay, which is displacement. We have, which is class, which is the class of the car. Two-seater, not displacement. Two-seater, compact, mid-size, minivan, pickup, subcompact, SUV. It's plotted those points according to their engine displacement and the mileage they get on the highway with color-coded groups. Each group has a different color code in the points, but the line has been added, the regression line has been computed, estimated, and added with respect to each of the 7 classes. And that's not what we want. We want one line to go through all of them. So what you have to do in that case is you have to be careful to put the aesthetic mapping of the color coding to class under the geomePoint instead of putting it up here. You have to put it under the geomePoint and then draw the line on that basis. And so if we do that, now you see we get one line regressed among all of the classes instead of separate lines for each class. And that's what we wanted, or that could be what we wanted. And so you have to be careful, because we have 2 layers, you have to be careful about where you map in parts of the aesthetic mappings.